All right, let's talk about our square root function. So the parent equation of this guy is y equals the square root of x. Our locator point is our good old friend, the origin, 0, 0. Our domain is actually restricted in this case because negative values don't work. So x needs to be greater than or equal to 0 to make our square root happy. Other features, there's not really any other features. And the range is also y is greater than or equal to 0 because you can't take the square root of a number and come out with a negative. Our graph, when in doubt, make a table. So in this case, the table can be a little trickier to make to get integer values. So you really want to think about what can I plug in for x that's going to make my square root produce a nice number, right? Those are our perfect squares. So let's try plugging in 0, 1, 4. Other numbers you could plug in would be like 9, 16, and so on. Those won't show up on our graph though. So the square root of 0 is 0, square root of 1 is 1, the square root of 4 is 2, and that is the extent of what we'll be able to see on our graph, but you could keep going if you wanted to. So 0, 0, 1, 1, 4, 2. Notice this is the inverse, or kind of like opposite, of a parabola, just on its side and cut in half. So there's our locator point at 0, 0. Let's take a look at our general equation. We have y equals a times the square root of x minus h plus k. Hopefully this equation is looking more familiar now. So as an example, we could look at y is equal to 3 times the square root of x plus 4 minus 3. Oops. I know this is kind of similar to the last one we did, but I wanted to make sure it fit nicely on the graph. So in this case, our domain, you want to look on the inside here. We need x to be greater than or equal to -4 to make our square root happy. And then our range would be all values. We know that this whole square rooty part over on the left can't be more than 0 or less than 0. So that means that our range is actually going to be all values greater than or equal to -3. That is very much related to our locator point, -4, -3. This is not called a vertex. We usually just call it a locator point. A vertex is restricted to when we're talking about a change in direction, like for absolute value or for quadratic. All right, so let's plot our locator point, -4, -3. And then from there, you can use the trick, right? If we know that our stretch factor is 3, then when I move 1 over, I better be moving 3 up. And when I move 2 over, when I move 4 over, rather than moving up 2, I'm going to do 3 times that. So I'm going to go up 6. Now that I know that's kind of confusing. So, oops. Let's also take a look at the table. In this case, our locator point tells us where to start. So at -4, we know that it'll be -3. What other numbers here are going to make our square root happy? So we want to be really mindful of what we put in for x so we can get nice integer values. Well, if I plug in -3, that's going to be great because -3 plus 4 is 1, and I know what the square root of 1 is. We can also plug in 0, right? Because if I plug in 0, the square root of 4 is a nice number. And I could plug in 5, and that's going to also work because the square root of 5 plus 4, square root of 9 is 3. So let's use that information. We know that at 3 will be at 0, negative 3 will be at 0. At 0 will be at 3. I'm just plugging it into my function here. At 5, I will be at 6. Sorry, I was a little off here, I guess, with my drawing, but that's okay. So again, the values that I chose to put into my table, to be mindful of what I'm doing, I chose to put in values that make x plus 4 a perfect square. Because that is what makes my square root happy and allows me to quickly calculate those table values. It's going to give us a better estimate than I see a lot of people try to put in these weird decimal values. Don't do that. And then our locator point was here. We started from that in this case because that's how absolute value functions, square root functions are. They start from a single point. They don't go towards the left. And that's all we got for square root functions.